This is an application on how to use the probabilities we discussed for the binomial, the binomial probability for sensitivity and specificity. So the way we're going to do this example is the following way. Let's suppose I have a test that has the following sensitivity. So the sensitivity of the test, which by now you should know it's the probability of testing positive if you actually have the disease, and let's say it's 80%. Also, that same test has a specificity, which you know by now it's the probability of testing negative if you're healthy, and I'm gonna go with 90%. Alright, so, and let's say in a specific clinic there are five, let's say, five individuals that are diseased, yani they do have the disease, they came to be tested. The question I want to ask, should a probability that out of these five that comes to be tested, two test positive? Okay, so I'm interested in positive. This is going to be my success, and therefore testing negative is going to be my failure. And I want to know, should a probability that exactly two are going to test positive. Now, is this a binomial wala la? The way you're going to know if it's a binomial wala la, you ask yourself, is this a Bernoulli event? So the question is, the testing has two possible outcomes. Yes, it's either positive or negative. And does the probability of testing positive or negative changes from person to person? If they are all diseased, the probability of testing positive doesn't change. For every one of them is 80%. Okay, so it's not changing. Therefore, it's actually a binomial, and I can set it up so that n, the number of trial, is equal 5. The number of success is equal to 2. The number of failures, therefore, is equal to 3. The probability of success is the probability of testing positive. La mean la those that have the disease, so positive giving disease, which you are given here, so that's 0.8. And the probability of testing of failure, that's the probability of testing negative. بعدنا عم نحكي على الديزيز، ما قربنا للهيلثي، ما في حدا healthy لحد هلا. So it's 0.2, and therefore if you apply the formula that we covered for binomial, probability of x exactly equal to 2 is 5 factorial over and the 2 success 2 factorial على 3 factorial, and this probability of success يعني 0.8 raised to the power of number of success يعني 2, and 0.2 raised to the power of, sorry my parentheses مش كتير واضحين, so 0.2 raised to the power of failure اللي هن 3, and you can actually get that value. Let me do the calculation. So I'm checking my calculation and I'm getting about 5%. I'm giving 0.0512. So the probability that exactly 2 of these 5 diseased people test positive and 3 will test negative, this is going to happen only 5% of the time. Now I'm going to shift my interest and asking myself, now what if I have, let's say, 3 healthy individuals, so they're not diseased, and they get tested. Okay, still a probability that it can happen that some will test positive and some will test negative. Defining what is success, what is failure, doesn't matter as long as you stick to it. So I'm going to call testing positive كمان a success on purpose, and testing negative I'm gonna call it failure. And I'm interested that out of these 3 people, 2 will test negative and 1 will test positive. That's what I'm interested in. Okay, يعني بدي out of the total يلي هن 3, the success being testing positive, but the only 1 to test positive and those that are considered failure, testing negative, to be actually the 2. The probability of success in this example is the probability of testing positive. However, for those that are healthy, they do not have the disease, and this is the complement of this, so it's 0.1. The probability of failure in this example is testing negative given healthy. Okay, and this is the 0.9. And now you can do your binomial, the probability that you get 1 that tests positive and 2 test negative. Again, you do the formula, يعني عندي 3 factorial over 1 factorial over 2 factorial. Take the probability of success, اللي هي 0.1, raise it to the power of successes, which is 1. Take the probability of failure, اللي هي 0.9, raise it to the number of failures, اللي هن 2, and that should give you the answer. Let me calculate that and come back to you. And by looking at my calculation, I think this, if my calculations are correct, let me just make sure that my calculations are correct. It's 24%. So it's 0.243. So the probability that out of 3 healthy, 1 will test positive and 2 will test negative, that's 24.3%. Okay? Alright, now I can also further ask you the question, what is the probability if 5 diseased and 3 healthy tested, should a probability that 2 of the diseased test positive and 1 of the healthy test positive. يعني أنا what I did here is I calculated هاي لحالة and I calculate this one alone. Now I can ask you what's the probability that they both occur at the same time. This is obviously an intersection, these two things happening at the same time. Yani A and B, the probability of A and B is the probability of A times the probability of B given A occurred. However, these things are independent. What is happening in the disease group does not influence what is happening in the healthy group. And therefore, these probabilities are independent, and therefore, all you would have to do is take this probability multiplied by this probability, and that would get you the answer to your probability. Okay, so if we stay with the same setup, if instead of asking you, so let me do شوية cleaning. All right. So بعدنا the same setup, everything, and the 3 the same sensitivity, same specificity, everything is the same. Now, if instead of asking you, should a probability that out of the 5, 3 will test positive, if I ask you what is out of the 5, if I say at least 3, so if I say at least 3 will test positive. At least 3, it means x has to be greater than or equal to 3. Okay? It means you need to calculate the probability of x equals 3, which you did. Then you need to calculate x equals to 4, and then you need to calculate x equals to 5. Each one of them is a binomial by itself, so exactly the way you did the first one, you're going to do the second one and the third one. Then you add these 3 together, and I'm doing it on an Excel, so for me it's easy to do. So by, let me show you on the Excel. So let me bring this right here. Okay, so if you remember, I showed you this in Excel. So I have the x could be 0 or 1 or 2 or 3 or 4 or 5. And over here, I typed in the formula, which is a binomial distribution. This is the number of success, comma. The number of trial is 5. The number of success is 0.8. And I do not want a cumulative frequency probability. So by doing it this way, I have all the probabilities. They should add up to 1. So إذا بعمل sum and I sum them up, I get 1. So the probability of at least 3, يعني 3, 4, and 5, I need to add up these 3 together. Let me do it here. So this is probability of adding these 3 probabilities مع بعضهم. and that comes out to be equal to 94.2%. So 0.942. Okay. On the other hand, I can also come here and ask you, show a probability that here, for example, at most one will test positive. So at most one will test positive. At most one معناتها your x is less than or equal to 1. يعني your x is equal to 0 or your x is equal to 1. We already calculated the probability for x equals to 1. You still have to calculate x equals to 0. Remember that here my success is testing positive. يعني مش 90%, 10%. So I go back to my Excel. Okay, I set it up here. قلت لكم the success could be 0 or 1 or 2 or 3. And the formula inside, notice that's the number of success right there. I have three trials, I mean. The success is 10%, and I do not want a cumulative probability. So a minute ago when I calculated 2 negative and 1 positive, it was this value right here. Now I want x equal to 0 out to 1 by adding these two values together. So let me sum up these two values. And it's 97.2. So by adding these two together is 0.972. Okay. Hella, if you are asked, show the probability that out of 5 diseased and 3 healthy, at least 3 of the disease test positive, and at most 1 of the healthy test positive. So this becomes an intersection. And what you need to do is, after you've calculated this and after you've calculated that, you multiply them together, because now I want to know the probability that these two occur at the same time. Okay? All right. Last, in the assignment, what I asked, all will be correctly classified. All will be correctly classified, معناتها, in this specific example here, what I'm doing right here, for this example, those that tested, كل الhealthy, all of the healthy ought to test positive, يعني x here ought to be equal to 5, وكل الdisease ought to test negative, يعني x over here ought to be equal to 0. Okay, now you calculate this probability, you calculate that probability, you get them together and you multiply them. بيطلع عندكم the probability of all testing correctly. وفيني أسألكم عكسها، شو the probability that all test incorrectly. So if I ask all testing incorrectly, now the number of success becomes 0 in the first one, and the number of success becomes 3 in the second one. You calculate that probability, you calculate that probability, and you multiply them together. Okay? Now I want to backtrack a little bit for this one. So هيدي all of them tested correctly. Is that all of them tested correctly? What is its complement? What is the complement of all testing correctly? At least one is wrong, without specifying if the wrong is in the disease or in the healthy. So if I ever ask you the question, what is the probability of at least one being getting a wrong test without specifying if it's in the disease or in the healthy, what you need to do is calculate the probability that all of them are correct, and you do 1 minus. You do 1 minus that, you get at least one incorrect test without specifying where is this incorrect test. So that's kind of like cover a quick overview of the last question in your assignment. I did not use the exact same values. However, if you use the same rationale I implemented here, you should be able to do the assignment.